Hello everyone and welcome to today's SANS webcast, Continuous Opportunity, DevOps and Security. My name is Carol Auth of the SANS Institute and I will be moderating today's webcast. Today's featured speaker is Ben Allen, Security Engineer at SANS. If during the webcast you have any questions for Ben, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. And with that, I'd like to hand the webcast over to Ben.
Thank you, Carol. Welcome, everyone, and thank you for joining us. There we go. Before we dig into the meat of the content, I just wanted to share information quick about a couple of new SANS courses that are coming up in November. We've got early runs where we're offering a 25% off discount. So November 7th and 8th in Nashville, Tennessee, Eric Johnson and I will be teaching the Dev 534 Secure DevOps, a practical introduction. And on the 9th and 10th of November, again in Nashville, Eric Johnson and Greg Leonard will be teaching the Defending Mobile Applications Security Essentials class. Again, both those available with discounted pricing, and if you're able to join us, certainly be great to have you there. Again, you can visit the SANS website and find out when any of the training is coming up anywhere in the world. So, quick bit about my background. As Carol said, I'm a security engineer with SANS. I worked in operations and development at SANS prior to my role in security. And prior to joining SANS full-time, I did network security work at the University of Minnesota for a little over a decade, I guess. Contact info is available. It'll be on the slide deck when they're posted after the webcast, so feel free to reach out if you've got further questions. So quick summary here of what we're going to talk about today. A quick high-level look at sort of the DevOps movement at large. Some bit about shifting security left in the process, moving it earlier, and we'll get into a demo of running the gauntlet and actually show some ways to integrate some security tools into the continuous integration pipeline. So to get a really good idea of where DevOps came from, start by looking at the past. The waterfall development model, which brought many great things to light, but also had many negative side effects. Very formal requirements and design and implementation stages, massive amounts of documentation handed off from one team to the next. Everybody worked in silos. And at the end of the day, very slow process. What got delivered wasn't necessarily what customers needed. And as far as involving security, most of it was in the verification and maintenance phase, very late in the process when it had become very difficult to change things because the requirements and the design had been set in stone, essentially, very early in the process. It didn't work well. Customer feedback came very late in the process. Handoffs had delays. Security was left at the very end. When these things were deployed, the development team packaged it up, said it's done, essentially threw it over the wall and said, here you go, operations, run this, and operations may have had absolutely no idea what they were getting and what needed to be done. Those long development cycles meant, projects often got delayed and ran over budget quite frequently. It also meant that something established very early in, say, the requirements or design phase, pinning an operating system version or a Java version, saying we're going to run with exactly this version. 6 months later, when it was delivered, it was known to be vulnerable, but there's this challenge of, we have this known vulnerability, but we have this long delivery time, and we can't change our underlying assumptions. So it left lots of vulnerabilities in software, in the operating system, in the underlying components for the builds, simply because of the structure of how things got released. As I mentioned, developers just kind of threw it over the wall, and often it wasn't developed with being easy to operate in mind, and the developers didn't have any incentive to make it easy to operate because they just did development. Over time, businesses saw that this wasn't working well, and part of that sort of progression, customers weren't getting what they wanted, and they started working with the business owners and development teams, and the Agile movement brought about shorter feedback cycles and getting the customers and the development teams working closer together to understand what's wanted and what's meaningful, and making shorter development cycles to deliver something useful, rather than having a very long documentation cycle to deliver something that was exactly what a customer wanted 6 months ago, but is now irrelevant. That extended into what is commonly referred to today as DevOps, sort of bringing the operations team into the fold and saying, not only is it important that we develop what the customer wants, it's also important that we're able to support and run that system in a way that we can grow our customer base without breaking our software or having to have 5 people on call 24/7 just to keep the system running because it's fragile. The next sort of phase that's, I guess, really coming into its own now is Sec DevOps. I've seen it as DevOps Sec. Take your pick. But opening up that pattern of increasing communication and making sure everybody who has a stake in the business outcome is there and able to help break down those walls, and bringing security in so that security can be involved in in every sprint rather than at the very end as a gate where that doesn't necessarily work in current environments. A lot of the DevOps movement has kind of it's been spurred along or been made visible, highly visible by some large companies, large leaders that have a presence and have talked about what they've done to change how they deliver and deploy their product and deliver their services to their customers. Excuse me. Etsy has done a lot discussing their just culture and how they do security within continuous delivery. They also do a ton of stuff with graphing and capturing metrics. Netflix has done phenomenal things with security in AWS, particularly in the area of resiliency, and their simian army of tools that will go and just randomly take down parts of Netflix as part of the regular operations to ensure that the service as a whole is resilient to small failures. Facebook and Twitter have both published tools, shared some of their processes, and contributed a lot to the DevOps movement at large. So as a case study, we'll take a little closer look at Etsy. In their beginning, well, I guess if you're not familiar with Etsy, they're a sort of peer-to-peer marketplace focusing on like handcrafted products. 1 million sellers, 21 million buyers. I'm not sure where that number's from. I would suspect they're growing and have grown beyond that. So looking back at their history, 2008, which is a long time ago in internet time, they had difficulty with scaling up their teams, particularly in engineering and operations. And they were releasing to production twice a week, and each release took 4 hours. So they were losing 8 hours of time for their sellers to sell products to their buyers every week. Painful for a company that's main business objective is to connect those buyers and sellers together. And they had a deployment process of a large enterprise. Read that as waterfall and shut things down, do the upgrade, turn things back on. Fast forward 4 years, this is still 4 years ago now, but they did a bunch of work with their organization, with their tooling, with their culture, and made fantastic improvements. They went to continuous deployment and deploy 50 changes to production every day. They make use of a technique called dark launching, where you put a feature out into the production code base, but it's turned off for the vast majority of users, and you can have a small number where you turn that flag on, and you can test something new and try it out in a small spot in the production environment, and validate that it does what you want it to and behaves the way it should, etc. Very big thing out of Etsy is their just culture and blameless post-mortem. So if something goes wrong, people don't get blamed. It's okay to make a mistake, provided you participate in solving the problem and you learn from it. And when you can push another change out in one change every 30 minutes, you can revert that mistake very quickly. I presume 4 years since then, 50 changes to production per day is well in their rearview mirror, and that they're doing far more today. I should look up the number, but developers and operations people take on-call rotations. And this helps with that issue of developers not understanding what it means to write software that is supportable by operations. Developers taking an on-call rotation helps build that knowledge, helps build that empathy for what it means to have something clumsy to run and have to support it. And Etsy measures and tracks everything. So 4 years ago, Etsy was, they were a high-performing organization. Puppet and I believe Dora is the DevOps Research Association. They've been publishing a State of DevOps report for the last 5 years, I believe. Highlights from the 2016 report: high-performing organizations deploy changes 200 times more often. So if you're deploying once a week and you're a low-performing organization by their standards, your competitor who is high-performing is deploying once an hour. Ballpark numbers. Lead times, so between a feature being approved to be created and delivered to being in front of a customer, are 2,500 times shorter. Change failure rate is 3 times lower, and failure recovery is 24 times faster. And one of the things that I found very interesting from the report is that high-performing organizations spend half the time that their low-performing counterparts do remediating security issues. So high performers spend less time patching, dealing with break-ins, etc., because everything's moving faster. It's a nice side effect. The link is there. DevOps report is pretty easy to find online as well. So I've been talking around sort of DevOps as a whole. Keep kind of navigating around it from the what is DevOps not? So it's not a tool or a product. It's not a prescriptive recipe that if you do these 5 things, you are doing the DevOps. It's not a job title or position necessarily, and it's not running systems in the cloud. Looking back at Etsy, they run their own physical hardware and data centers, so they are doing DevOps, but they are not in the cloud. It's not a way to get around having IT processes that are slow and cumbersome. It's not an end run around supported IT processes. And it's not the same in every organization. How you get to DevOps is very different depending on what your organizational culture and structure might be. Adam Jacob of Chef has a presentation called Chef Style DevOps Kung Fu, and one of the sort of themes throughout the talk is DevOps is a lot like Kung Fu, where you might not be able to describe it, but you know Kung Fu when you see it. One of the best descriptions I've seen for DevOps, describing it in the positive, is from John Willis, who was with Chef at the time when he wrote this blog post of what DevOps means to me. And his characterization focused on sort of 4 main aspects. Culture, so having people supported, and from the case study at Etsy, it's okay to fail. That's a cultural thing. And you have to have that in place, or trying new things won't be acceptable. Automation, which is it's huge. If you're going to do deployments 50 times a day, you can't have an hour-long manual checklist to do a deployment. Measurement, so making sure that you know what's happening, if things are getting better or worse, and how quickly they're getting better or worse, so that you can improve. And then sharing, so making sure that, and this can be from having the operational metrics available to development and business people. It can be to giving presentations and conferences about how your organization has changed and what the benefits have been. So sharing can be a very wide thing, but at the end of the day, having the access to the data about how your organization is performing helps everybody have a stake in how to improve the organization's performance. So, touching a little bit on automation, just because that one's maybe a little more tractable and something we can demonstrate. But there's a range there as well. So, from configuration management, automating how you build the operating system, how you build your containers, building the lowest level blocks of your infrastructure, continuous integration to so taking your code from source code, if you compile it into Java, or minify it or transform it in some other way to have it be a artifact that you can then deploy and test and reuse. Continuous delivery, so taking that object or that artifact that you're going to deploy, performing your testing against it, making it ready and available to deliver into production. Continuous deployment and delivery, the differentiating factor there is that in continuous delivery, you get it push button ready so that the code's been built, artifacts have been created, it's been tested, it's ready to go. A human hits the button and decides. In continuous deployment, that last human step goes away. You say, if it's been tested, take it to production, that's where we want it, it's all good. And continuous monitoring, just once it's in production, you start getting data back. You use that data to inform, how is it behaving? Did this build cause a performance problem? Did it solve a performance problem? So on and so forth, so that you're monitoring things all of the time. So I'll pause here and shift topics a bit. We'll look at how security reacts to going from twice a week to 50 deploys a day. If you're coming from a waterfall perspective and you're used to having the week to do pen testing and another couple weeks for a source code assessment and control gates where security gets to review things, there may very well be a tendency for you to kind of freak out at this thought of having 50 deploys a day or 100 or several hundred. And the question, how can security keep up with this rate of change? And the short answer is it's not by doing things the same way as security has done things previously. So as Agile and shifting to DevOps have broken down some of the barriers between the various phases of getting a feature that a customer has requested into functioning code that's in front of those customers, those cycles of plan, develop, test, release, deploy become faster. They also become smaller things to check, and security needs to move and start being involved earlier and earlier in the process, and eventually be involved throughout the entirety of the process. So doing threat modeling during planning, simple things like, does this data we collect about a user, do we need their gender? Do we need their birthday? Is there, is that PII that we need to protect differently that we want for convenience, or is that fundamental to delivering the service that we exist to deliver? Lots of development practices will do unit testing and test-driven development, and the vast majority that I've seen focus those unit tests on, does this piece of code operate as expected under expected inputs? And sort of, does the happy path work right? Pen testers and hackers and attackers are continuously probing to see, does your application behave to the attacker's advantage when not taking that happy path? So writing simple unit tests for, does an apostrophe in a password get handled correctly, helps move that, those security tests very early in the process, and you can detect issues very quickly and prevent them from moving their way into operations where they become more expensive to fix and also open to attackers because it wasn't just something that got detected in the sandbox or in a pre-release code scan. The other thing you can start doing is adding in small source code scans, and in your development pipeline, maybe you only want to do incremental scans within the pipeline just because code analysis can take time and can be rather expensive in some cases. You can't hold up a development pipeline for 2 hours if you're going to release 50 times a day just to do static code analysis. But you can do a minute to check the code that has changed. So taking our case study of Etsy here and taking another look at it, they, in the interest of sharing, they have shared a lot of information about what their security program looks like. They've got sort of 7 main aspects of it, and it starts out with don't be a jerk. So security coming in and saying, oh, you developers are terrible, you introduced this vulnerability here, isn't acceptable. What they encourage is the security team to come in and say, hey, look, I'm seeing a lot of these kinds of vulnerabilities, but if we add this into our framework where we're building our code, we can prevent it everywhere, and the security team helps out. If it moves, graph it. The StatsD protocol and tool set that Etsy has published and shared with the world is phenomenal and lightweight, and you can throw lots of very good information into there, from OS level metrics up to, your application can generate information about what it's doing. So were carts abandoned, was there a login failure, etc. Any engineer can push code out. So if a security engineer sees an issue that got missed, they can make the change, go through the build process, push it to production, and get it fixed, and then go back and start discussing how did that flaw get into the system to begin with, and solve the wider problem after the fact. But security can help in, jump in, help out, make changes to production and get it done. That would be the same as, if there's a new OpenSSL version being released because there's a flaw in the old one, security can jump in, make that change, and push that out to production because they have the ability and they have the knowledge. Last four, just to grab them real quick. Security cannot be a blocker, which covered pretty well in the first three there. They will have designated hackers who work with a small number of projects. The engineering teams and security teams will do job rotations so that developers understand what the security team's doing. The security team understands what the day-to-day life of a developer is. And they do both internal and external bug bounties. So what do we get out of all this? So as we bring security into the discussion earlier and earlier in the process, it becomes a first-class citizen during the development workflow. So there's a number of static application security testing tools, many of which can be hooked into the developer's integrated development environment. So when you save a file, it'll run a bunch of tools locally on your machine and say, hey, these 4 lines, in addition to not following our style guide, they're introducing a vulnerability that you might have missed. And when you can have that feedback right there as the code's being written, that's optimal. That will prevent a lot of things from making their way out to production. When you commit code to a code repository, you can trigger out-of-band scans. So you know what? Yep. Code in this repo got changed today. Make sure it gets scanned tonight. You can add them to the build pipeline if you keep them narrowly scoped and make sure that they are accurate and lightweight. So maybe a scan of just the file that changed, or just the small number of files that were changed in a commit. And then cataloging and identifying your high-risk code. So as a security person, I might say, we wrote this library where we're handling usernames and passwords. If that changes, I want to know. And just adding that to your continuous integration pipeline to say, here's my list of functions and where they exist. Anytime that code changes, send an alert to the security team, and it doesn't need to stop the pipeline, doesn't need to stop code from being delivered to production. It just means the security team is made aware of that change, can come back in and do a manual code review of the changes. Security team can come back in and if there's something ominous in there, go back, fix, and push it through again to undo a created flaw and get that out the door so that there's an opportunity to minimize that exposure time. The key in all of this for continuous integration is that the feedback needs to be accurate. So false positives in a deployment pipeline they're not going to be well received. It needs to have a clear pass-fail result, and it needs to be fast. It can't be slowing down. Doubling the time it takes for the build pipeline to run to do a security test is not going to, that's not going to be seen as, doubling that time will be seen as a blocker rather than as security finding a way to help out. There's a lot of tools out there. Pick your language, search for static analysis tools. Many of the commercial tools support multiple different languages. And one aspect that has popped up as sort of a market unto itself fairly recently, as frameworks become more modular and you can bring in components from different suppliers, if you will, and you build up this, my framework plus 35 components, and I write this very tiny thin app because most of what I need has already been done for me in various ways. I can just put all these pieces together. There are tools for checking that all those dependent pieces that you rely upon are actually secure. So they'll track the announcements from all sorts of these different vendors and make sure that, hey, this component that you're using, that got upgraded 2 days ago because of a critical security flaw, and it will start flagging those things in your build pipeline and say, hey, look, you're relying on this component, but it's now turned out that the version we're using is vulnerable. We need to address that. So again, there's a mix of free open source tools and commercial tools available to help out with that, with making sure that you have a clean supply chain coming into your your application build environment. Another category is the sort of dynamic application scanning. So looking at doing a full web app pen test, automating that in the delivery pipeline, doing a full goal of 100% coverage kind of black box scan isn't really a good fit for a delivery pipeline. But you can use those same scanning tools and scope them down and say, every time we do a code deploy, I'm going to check these 5 pages for these 3 flaws because we know they're important enough that we'll take the time on that. And checking the login page, checking password reset, checking the account sign up, making sure they're not vulnerable for SQL injection, can be a very good investment and a very small cost. Functional security testing, sort of going back to what I was mentioning earlier about having unit tests that test the happy path and adding in some unit tests for unexpected things that are outside the happy path to make sure that they're handled correctly. This is sort of taking that at the next stage of, when you've actually got the app up and running, you may write a functional test that says, the tests, can a user log in? Well, take that a couple steps further and write the functional test that says, can a user, or does an account get locked properly when a user tries to log in with the wrong password X number of times in a minute? And you can also start, adding in more complex tests, perhaps out of band from the delivery pipeline, but to keep, continuously testing your environment to make sure that authorization works correctly. Password reset, password management, password change tools work properly. Again, there's lots of tools out there for doing that kind of testing. There's open source and commercial. And there's sort of a separate set of tools that exist more as a framework around, I guess, orchestrating a bunch of other tools. So for example, Gauntlet can support W3AF and curl and Nmap and a bunch of other things so that you can use one framework and which will allow you to drive multiple different tools in a singular manner. So as we continue to look at where security can integrate into the processes that are in place for development and operations teams, monitoring becomes a phenomenal source of data. So if you're graphing your web traffic or your web server response codes, or application things like authentication failures, access control exceptions. User Ben attempted to access the payroll portion of the application, and his access was denied. Tracking some of those kinds of things, and sending them, graphing them. You can start correlating that information. You can start just even looking at it will help you find trends, find anomalies, and help you understand what your environment looks like. And if you see a large number of 500 errors and some database syntax stuff, well, somebody find an SQL injection flaw? You can start looking at the data that's already being captured for operational support, and look at it through the security lens, but use the same tools and say, okay, how do we graph something? How do we look at how can we look for different types of attacks with the data we have in front of us already? Number of approaches that are really, really solid. Check out Christopher Raimondi's video on YouTube about using DevOps tools to increase security visibility. Excellent approaches. I highly, highly recommend looking at that talk and getting some ideas from there. So give an idea, we'll use Etsy again since they have shared so much of this with all of us. They've got a wall of monitors in their office area that shows a bunch of different things about all their environment. Don't know if it shows real clearly, but I believe in the bottom left and bottom right, those little vertical lines are most likely showing when code was deployed to production. And that gives you an idea of how frequently that's happening. But you can also see that if one of those had dropped right after a deploy to production, that would be that would be something that becomes actionable very quickly, just because there was a deploy, something changed. Let's go look at that. And in this case, these seem to be, without being able to read the monitors in there, relatively low-level performance metrics about how the system and how the environment is operating. When you've got the data, you can bubble that up, a number of levels. Capital One developed a tool called Hygeia, and they shared it with the world on GitHub, and it takes a look at the development process from a very high level. So, how many issues are open in this sprint? What's the activity been in the source code repo over some time period? What's the build health for this project been like? How many builds have failed? How many passed? When? How much coverage have we got on our tests? How are we doing for passing and failing our code quality tests? And how frequently are we deploying to our different environments? And being able to see from a very high level, this project is healthy and behaving well. New features are being delivered, work is being done, and it's being done to our standards of quality. exceptional level of visibility when you can see what's going on there, and you can take a look at this per project and see how healthy is this project or this product over a long period of time. Alrighty. So, taking a look at some of the motivations behind DevOps, skimmed across some tools about how to shift security into earlier into the process. So now we'll get to a little demo, but before that, I'm going to introduce the things that we're going to have in the demo here. So we're going to be working with OWASP Bricks, which is an intentionally vulnerable web app. So each little brick has a specific security issue, and it's designed as an educational tool. You can take a look at the code. It's very, the bricks are, each brick, it stands alone very clearly. It makes it easy to see, from a code level, oh, here's where the flaw is. You could use it to go test fixing it, etc. Really handy open source project there. We use Gauntlet, which is as they say from their website, a ruggedization framework to enable security testing that's usable for devs, operations teams, and security. It uses a commonly used syntax for writing tests. It uses a given, when, then structure to it, so it's very human readable, it's very expressive. If you're already writing functional tests, that Gherkin syntax is very popular for functional test work, so it would be unsurprising if there's already somebody in your organization who knows how to use that. And Gauntlet has adapters for a bunch of different underlying tools that will actually do the work. Additionally, it supports an output format called JUnit, which is the output format lots of unit testing tools will use. So you can run a security tool, output the data in the same format as a unit testing tool, and that helps integrate with pipeline, since there's not a new, the pipeline automation framework doesn't have to deal with a new input format. We'll use the Arachne web app scanner. We're going to be using just the command line scanner, which is a very small piece of the overall framework. There's a lot of other pieces which, for a continuous integration pipeline, might not be necessary. However, for a more comprehensive application security program, could be a really good fit. It just so happens Gauntlet has an adapter for Arachne. And we're going to use Jenkins as our automation server or automation engine. And we've got a continuous integration and continuous delivery pipeline built with Jenkins. And so at a high level, our demo environment, we run Jenkins. We use it to build and deploy bricks as a Docker container. Part of that build and deploy process includes running a set of acceptance tests, which happen to be run by Gauntlet. So for our demo here, we're going to add an Arachne scan to the acceptance test process. All right, so here we have our Jenkins dashboard. We can see that this is a continuous delivery process because we have not, or because we require human interaction before we deploy things out to production. So we'll go ahead and do a deploy. While that's running, we'll take a look at the version of bricks that's currently running in our production, air quote, production environment. So home. Right now there's 3 different categories of bricks that you can attempt to smash. So we'll take a look at basic login, and login has been, password is wrong. Let's never remember. So bricks will tell you, here's what the query that was generated looks like. You can use this to figure out how to perform an SQL injection attack and break the brick and actually log in without knowing username and password. Okay. So Jenkins was deployed. As mentioned, we're going to add an acceptance test. So here we run the acceptance test. We've got a result set. It says it contains 8 results. Take a quick peek at our results. And this is treating the tests as unit tests. So the output is very thin, very minimal. So check the site title. What we get as the response is that it passed. So we use mmap to verify ports and server config. And the step was check site title, that passed. Not a lot of detail, but there's ability to get a lot of data in there, and it's clear pass-fail. It's quick and it's actionable. So if we jump back to the acceptance test project, we can take a look to see how those acceptance tests are actually run, which will help us figure out how to update them so that we can run an Arachne scan. So we've got some Jenkins set up. Okay, so we're checking the source code out of a Git repo, applications bricks. So that's part of the bricks code base. We run it after this other job is launched stably. We list all the attack files in the workspace, and we run this script that's in that Git repo called run acceptance tests, and we give it a parameter called target. And after it's done, we go and find any sorts of warnings that we've got, and we do a JUnit test report on all of the test block XML files. All right, so that's where having that output format in JUnit from Gauntlet, Jenkins can understand and parse that and give us a nice, high-level roll-up of the test results. So here we've got that Git repo for the bricks application checked out, and we'll take a look and see what are all our attack files. Okay, and we also want to take a look at build bin run acceptance tests. So we get a parameter called target. Sets this environment variable, it sets an args thing which will include smoke and acceptance tests. So Gauntlet has the capability of grouping tests, and you can run different groups, so based on their tags. So we're going to, when we are called with the target, so in our acceptance test phase in the continuous integration pipeline, we're going to run the smoke tests and the acceptance tests. And then we've got a Docker run command that launches all of it. All right. So we found all those attack files because those are what Gauntlet uses for its test cases. And we know that the smoke tests are already running. And do we have any acceptance tests running? So nothing tagged with that. And we also have this XSS Arachne scan attack file sitting there, but it has no tag. So let's go take a look at that file. Let's see what it looks like. So we note at the top, hey, this test is really slow. We want to add this scenario to the acceptance tests. So we'll put that tag right there. And the scenario, which will get reported up into that Jenkins tree of what the test names were. Scan a bunch of pages looking for new cross-site scripting vulnerabilities. So here's that given when then syntax. So given a number of things here. So given Arachne is installed, and we've got an environment variable set, and we've got some internal variables that, in case we want to tune the scan, we can just change them here. If they're reused, we can reuse them later. So given all that, when I launch an Arachne attack with this command here in the triple quotes, so Arachne check for cross-site scripting, we set a number of other configuration options, and at the end we say scan our target host using the protocol we specified, which is HTTP. Then, so after the scan is done, we look at the results. Then the output should contain issues were detected. I'm going to come back to that bit a little bit, but let's take a look here. So let's see. Yep. Okay, we've got a target host and variable defined. So we should be able to do gauntlet. Tests, gauntlet, bricks, XSS Arachne attack. And if you've used Cucumber or something similar to do unit testing, the output will look very familiar as, we establish our givens. When we run this attack, then the output should contain issues were detected. So we went through all 5 steps, we had one scenario, and it passed. Okay, that looks good. We've got a test that passes. And so we did make that change where we added the acceptance test to, or the acceptance tag to the test so that the acceptance test script will pick it up and run it. So we can commit this, push it up to our source code repo, and then we will see it run the next time we come through this whole build process. One thing I did want to come back to, though, is that being careful about how you write your tests. Issues were detected is maybe a bit too generous, because that would also match 10,000 issues were detected. It also match 0 issues were detected. If we really want to be checked, we should say 0 space 0 issues were detected, so that we don't have a leading 1 or 5 or 300 in front of that 0. So that maybe is a more honest or more accurate test to say we have no cross-site scripting vulnerabilities in our application. However, we're targeting bricks, which is an intentionally vulnerable web application, so perhaps that's not a realistic expectation. And if we run the Gauntlet's test suite again to run this Arachne scan, we can see that that now fails. It also happens to put a lot of output. So let's we'll let the computer do the searching for issues were detected. We knew was in there from before. So we can run this again and check to see how many issues are actually in this code base. While that's running in the background, we can see here there were 9 test results from this set. There were 8 from before. So if we go look at our test results, we can see here in bold we added this user Acme to scan for cross-site scripting test, and it passed. And you can see the scenario name, scan top 4 levels or 100 pages looking for new vulnerabilities, and that also passed. So there we have the data flowing right back into Jenkins, folding in where it's immediately usable and useful. So we've got expected 0 issues were detected. What we saw instead was 12 issues were detected. So jumping back real quick to Etsy's sort of 7 pillars of one of them being make reasonable trade-offs. One approach for this situation would be to say, we're going to set this to be, we will allow 12 issues, otherwise we fail the build. If that number goes down, we update the test, and we keep driving this towards 0. If it goes up, we fix the code change that brought it up, and we prevent adding new vulnerabilities. So that gives us our demo. And just to quickly wrap up, there are massive opportunities for security in DevOps. And if we're thinking forward and thinking about how the tools and automation and collaborative sharing culture can be a boon to security rather than something to fear, we get to build things into the pipeline, prevent regressions. We get to reduce the time we're spending on security remediation. And we can get rid of ineffective, inefficient point-in-time compliance snapshots and trade them in for continuous validation that our environment is behaving as designed and protecting our data at the level we deem appropriate. Additionally, with all the graphing and things that are available, we can help build a shared knowledge of what it means for an application to be sitting publicly on the internet and what a hostile environment that is, which will help others within the organization understand why it's important to actually develop with security in mind and to build security in from the beginning. And it becomes a positive, a virtuous cycle where those things feed each other. And with that, Carol, it looks like we do not have time for questions. But thank you, everybody, for attending and listening in, and feel free to reach out to me afterwards for further questions.
All right, thanks, Ben, for that great presentation. We did have a couple of questions that came in, and I had let them know, and anyone else who has questions, go ahead and submit them to q@sans.org, and we can forward them to Ben. So anyways, yes, thanks, Ben, for that great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, you can visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.